4C. Because we have 4.
Here's the problem that we're going to work with today. And I will tell you, Park, they love comparing functions and proportional relationships. Here is our situation. The table and the equation show the rates at which two different printers print in terms of pages per minute. We're going to find the difference between the per page rate, and we're going to figure out which printer prints faster. So here we have two printers. Printer A, we have this table, and printer B, we have this equation, where X is the number of minutes and Y is the number of pages printed. You'll see this a lot. One equation, one table, maybe a graph and an equation, maybe a graph and a table, to see if you can work seamlessly with all types of representations. How can I find the number of copies made in 1 minute using the table?
You look at the 1.
Which one?
The first one.
What? So if someone say again?
You look at the number of minutes.
The 1 minute. It's good. If I'm looking where there is 1 minute, I can figure out how many pages were printed. What if I didn't have this value? What would I have to do on my table?
Divide.
I'd have to divide to get a big one. And here my big one is 1 in 40. What about in my equation? Where can I find my pages per minute in my equation? So for those of you, if you can't see it in the back, the equation is y equals 50x. For printer B, what are the pages per minute? Does anyone know? Just by looking?
50.
Okay. 50. How do we know that it's 50?
Because the coefficient
Say louder.
is unit.
Yeah, the coefficient of an equation in my proportional relationship is my unit rate.
It's not 50.
What?
40.
For printer B? Oh. Yeah, we're on the other printer. So printer A, in the table, we found it by looking where our number of minutes was 1. In our equation for printer B, our equation is y equals 50x. We're able to find the number of pages is 50 because of the equation. So when we compare these relationships, sometimes, depending on the question, it may be a challenge to look at a table and look at an equation and kind of see them the same. It's almost like the saying, you're comparing apples to oranges. It's hard to pull information. So sometimes we may want to put both situations into the same format. If we already have printer A as a table, could I put all printer B's information into a table and then compare maybe easier?
Yeah.
Potentially, yes. How can I fill printer B into this table? Who has one coordinate that we could put into the table? Sarai.
1 minute equals 50.
1 minute is 50 pages. Laura.
2 minutes is 100.
2 minutes, good, is 100 pages. David.
3 minutes, 150.
3 minutes, 150.
4 is 200.
4 is 200. Good. And how did they come up with those values? I know right now it might look like they just increased by 50 because they did. But if I had like a more complex equation, maybe like y equals 1.7x, what are we doing to find the values on that table?
You're adding 1.
You can constantly increase that value. And if I wanted to use the equation, what could I do?
Like plugging in.
Yeah, I could plug in the numbers or substitute in. So now looking at this table, can I clearly see which printer has the greater unit rate?
Yes.
Absolutely. If I refer back to where you told me to look for printer A for the unit rate and look in the same spot for printer B, I can see that printer B has a unit rate of 50 and printer A has a unit rate of 40. How can I write an equation for printer A? We already had this equation for printer B. What if I just wanted to look at both situations as an equation? Who knows the equation for printer A? Sorry.
Y equals 40x.
Y equals 40x. And where did she get the 40 again?
The unit rate.
It's the unit rate. Absolutely. Perfect. Now the other option, we can put them both in tables, we can put them both in equations, or we can put them both on a graph. By looking at that graph, do you see which one is growing faster?
Yes.
Which one, the diamonds or the boxes? The
Oh, it
boxes.
looks like
If
a
I'm
diamond.
looking at a line, what's indicating to me that the boxes are moving faster than the diamonds? Like, well, how do I know here, just by looking, that printer B is moving faster than printer A?
Because the slope is 3/3.
Because it's steeper. Yeah, it's moving faster. Think about this. For 1 minute, look how much more this printer prints than this one. And then at 2 minutes, the gap is growing even more. It's shooting up instead of being a little bit flatter. How can I find the number of pages per minute if I'm looking at a graph? Like, where is that unit rate on the graph?
The first dot.
Say again.
The first dot.
Is it always the first
No, it's not.
coordinate? And I'll change your terminology. Where specifically? I'm going to look where what value is what? The number of minutes. I'm going to identify on my graph where the number of minutes is 1, which may not always be shown, and these represent my unit rates. What are the slopes for each line? Who can tell me the slope for printer A?
40
40. How do you know that?
because 40 is the unit rate and the unit rate is your slope.
So 40 is the unit rate, and the unit rate is our slope. Let's say I forgot that. I forgot that the unit rate is the slope, and I needed to look at the graph and figure out the slope for printer A. Go ahead.
When I do the rise over run, even with the second one, even though it was 80 to 2, when I simplify it, it goes back to 40 over 1.
So that's a really good point. Jordan used her rise over run. Who remembers what that refers to? What's the rise?
Constant of proportionality.
It is in this scenario.
The rise is the y and the run is the x.
So the rise is the y and the run is the x. What specifically about that y value?
Y2 minus Y1.
Good, you're pulling out the formula. Y2, what does that mean?
Wait, what? Oh yeah, I remember this too.
That's a really mathematical way of telling us what? What's our rise? How are we finding it?
How much the Y is going up.
How much we're going up, or in some scenarios, down, compared to how much we're going left to right. And I like how Jordan pointed out two things. Our rise, oh sorry, I went too far. Our rise here of 40 and over 1 would give us a slope of 40 over 1. But what if maybe that coordinate wasn't on our graph and she decided to go to a different coordinate? From here, oh sorry, again, I keep trying to go to printer B. Up 80 and over 2. 80 over 2, if I simplify it, they're the same. Now let's say I asked this question for printer A, and I had a student say, the slope is 2. The slope, when I do rise over run for printer A, is 2 over 1. What did that student do wrong?
He didn't
Patrick, what did the student do wrong?
Instead of putting 40 as the rise, he put that he went two spaces up
Why 2? Where did that student come up with 2?
because it's like 2 lines.
Because on this graph, I'm really moving up 2 lines on my graph and I'm moving over 1. That's a very common mistake. The slope is representing our actual change in y, not just how much my graph might be moving. So here I'm going from a value of 0 to a value of 40, which is why it's an increase in 40, not an increase in 2. That's a very common mistake when we work with slope. So how can I get the slope of printer B if I needed to use my graph? I can use my rise over run again. What is my rise and what is my run for printer B?
your rise for printer B is 50
Okay.
and your run is 1.
Yeah, a rise of 50 and a run of 1. Which means for every 1 minute, 50 pages.
Someone else? Zero.
Zero.
Yes.
How would you put the formula in? How would you put
Good question. This formula, we're going to use this a few other times. Again, we used it yesterday, or 2 days ago. So this formula represents the second y value and the first y value over the second x and the and the first x. So let's take this example. We're going to use, let's use this one. We'll use this coordinate and this coordinate. We're going to go into more detail tomorrow on how I can use any coordinates on a line to find the slope. What is the coordinate of this point, or ordered pair? 2 and 80. And what's the coordinate here?
1, 4.
So if you were talking about your rise over run, some students might see this and say, well, I'm going up from 40 to 80, so I'm going up 40. And I'm going over from 1 to 2, so I'm going over 1. We can use this formula though. The second y value here is 80. So I'm going to take the difference between 80 and 40,
40.
which is 40. And that's just a mathematical way of finding the difference between these two y values, which represents our rise. And then the run would be the second x value of 2 minus the first x value. We're looking at the difference between where we went and where we came from, which would be 2 minus 1 or 1. So this represents the rise, and this represents what we refer to as the run.
How is that equation developed? Like, it just seems so.
We actually are going to, I think we're going to derive that equation and see where it came from. I think. Don't hold on.
Quote me on.
Y is y2 and x2 always going to be greater, like the rated?
Not necessarily. You could actually do it the other way.
And then the
Right. It's still going to be, it'll still give you the value. And that's a good question. Your questions today are awesome. Let's say we did it in reverse. And we did, we said instead of 80 minus 40, it was 40 minus 80. And then we did 1 minus 2. Now, it would have to be, if you're going to use this as your y2, then this would have to be your x2. Right? But what would this become? What's 40 minus 80? Negative 40. And what's 1 minus 2? So what does that simplify to? It still ends up being the same slope. That's a really good question. Sometimes students do that. The key though, and sometimes you may want to just label it like, oh, this will be x1, this will be y1, this will be x2, this will be y2. That's a great question. So what is, going back to the original question, what is the difference between the pages per minute?
10.
10. And which one's faster?
Printer B.
Printer B. Yeah, 50 pages per minute. Now we want
Mr. Quinlan, please come to the main office. Mr. Quinlan, thank you.
We want to be really careful because depending on the context of the problem, it may not be the larger number we're looking for. For example, if I had 2 runners and I was talking about who's faster, if I'm a faster runner, how much time do I, like if we race and I win the race, which means I'm faster, how much time did it take me to complete the run?
Less time.
Less time. So think about the context before you jump to it. Like if I beat you in a mile, maybe my mile was 8 minutes and your mile was 9 minutes, right? Because I ran faster, my number is lower. It depends on the context.
Yeah.
So try not to assume. So the first thing, we're going to start to do this in small groups, then we're going to break off independently. So together, here is our situation. We're going to compare 2 relationships. The price for X pounds of almonds at the Snack Shack is represented by this equation, y equals 6.5x. And the cost at the Nut Hut is shown in the graph. So you are going to determine with the people that you are sitting next to, which store sells almonds at a lower cost, at a lower unit cost, and how much lower. We're going to take 6 minutes. Don't assume. Show your relationships in a similar format so that you can prove that your justification is correct. Okay. I am going to actually pause the recording while you work, and we will go over this at the end of the 6 minutes. So working in your small groups, let's determine which place has a lower unit cost and how much lower.